This video has the solutions to the lesson 6-2 day 2 assignment. The assignment was to multiply fractions and also to raise a fraction to a power. We studied two rules. The first is for multiplying fractions. To multiply fractions, multiply the numerators and multiply the denominators. Simplify before or simplify after multiplying. I prefer simplifying before multiplying. One reason is it makes the numbers smaller that you have to multiply. A second reason is that a lot of the problems in the assignment you have to do by simplifying before. The second thing in this assignment is to raise a fraction to a power. You raise the numerator to the power and raise the denominator to the power. Okay, question 1. Which of the two rules applies? This is multiplying fractions. This is the first rule. Again, I prefer to do the canceling first to reduce the size of the numbers being multiplied. There's a 4 in the top and an 8 in the bottom. They're both divisible by 4. You cancel them out and replace them with what's created when you divide by 4. You can reduce the 21 and the 7. They both divide by 7. You cancel them out and you write down what you get when you divide by 7. Now multiply the numerators and multiply the denominators. Problem 9, this is multiplying fractions. I'm going to do the reducing first. There's a 6 in the top and a 3 in the bottom. They both divide by 3. 6 divided by 3 makes 2, and 3 divided by 3 makes 1. There are x's in the top and the bottom, so canceling will occur. The 2 x's in the bottom will cancel away 2 out of the 3 x's in the top, leaving 1 remaining. In the numerator, 2 times x is 2x, and in the denominator, there is only a 1 remaining. It's not necessary to put a 1 in the bottom of a number, just say 2x. Number 15. There's a 4 in the top and a 6 in the bottom. They both divide by 2. 4 divided by 2 makes 2, and 6 divided by 2 makes a 3. You can't reduce the 9 with anything. There's no number in the numerator that has a GCF in common with the 9. Now the variables. There's a letter E in the bottom, which can cancel the letter E in the top. There is a letter F in the bottom, which can cancel one of the 2 F's in the top. Cancel the exponent and replace it with a 1. The letter D in the bottom can cancel one of the letter D's in the top, leaving 1 D remaining. In the numerator, there is a 2, there is a D, and there is an F. In the denominator, there's a 9 and a 3. 9 times 3 is 27. Now please remember that you can use a calculator to do the multiplying and the simplifying for the coefficients. You cannot use a calculator to work with the variables. For example, if you go back to question 1, multiplying fractions, and there aren't any variables at all, you could simply type that in a calculator. Here is the TI-30 that we normally use. Push the N over D button and type the first fraction in. 4 on top, 7 on the bottom. Then type multiply. Push the N over D button again. 21 on top and 8 on the bottom, and push enter. The result is 3 over 2. And that's the same answer that we got when we did number 1 on paper. Now a problem like number 9, it has numbers and variables. You cannot do the variables on the calculator, but you could type the numbers in if you needed to. If you use a calculator to work with the coefficient numbers, then you have to do the canceling of the variables by hand on paper. Now, number 17. This problem has a different structure. This is our second rule. This is about raising a fraction to a power. You raise the numerator to the power, and you raise the denominator to the power. 6 to the second power is 36. Number 19, this is a fraction being raised to a power. You start by taking the numerator and raising it to that power, and then raise the denominator to the power. The numerator has two factors. There's a 2 and there's an n. You need to raise them both to the second power. 2 to the second power is 4. N to the second power is n squared. In the bottom, 7 to the second power is 49. If you're not very good at figuring out powers, use a calculator. For instance, maybe you don't know that 7 to the second power is 49. So use the TI-30 calculator, type in 7, and then on the left side of the calculator, about midway down, there's this button with the little white arrow pointing up. You push that button, and now you can type a 2 in the upper corner of the 7, and push enter, and it says 49. Now question 21. This is a fraction being raised to a power. Start by taking that numerator and raising it to the power, and then do the denominator raised to the power. The numerator has two factors, a 2 and an a. Raise them each to the second power. 2 to the second power is 4. A to the second power is a squared. Now in the denominator, take the 5 and raise it to the second power, and then take the b cubed and raise it to the second power. 5 to the second power is 25. B cubed to the second power is b to the 6. Think about what the second power means. It means you have b cubed times another b cubed. When you add the exponents, that's b to the 6th power. Okay, number 23 is the same idea. Take the first thing in the numerator, the second thing in the numerator, and the denominator, and raise them all to the 4th power. Start with the negative. A negative raised to an even exponent is a positive answer. X to the second power raised to the 4th power is x to the 8th power. Down in the bottom, we get 10 to the 4th power. 10 to the 4th power is 10,000. Again, if you don't know what that is, use a calculator and type it in. Now, it's not normal to write a positive sign in front of anything, and so you really wouldn't put that positive sign in front. Okay, now number 35. We're back to our first rule about multiplying fractions. And now you'll notice why I said that you have to do the simplifying first. The first 2 days of Chapter 6, we practiced simplifying fractions in which there were polynomials that can be factored. In this particular problem, this portion of the problem, the c squared minus 4, can be factored. Your first step is to factor that. We can rewrite the problem as c plus 2 over c squared times 3c over, now here comes the factoring, c plus 2 times c minus 2. The reason that you factor is so that you can now cancel common factors top and bottom. The c plus 2 cancels out the c plus 2. This letter c that's in the top can cancel away one of these, creating a new exponent of 1. Now let's write the final answer. There's a 3 in the top. In the bottom, there's a c followed by, in parentheses, the binomial c minus 2. You probably noticed that this is combining together our recent topic about multiplying fractions with the first topic in Chapter 6 about simplifying fractions by factoring them and canceling. Now, number 37. Before we can multiply these fractions, we need to do the canceling, the reducing. In order to cancel anything, we have to have factored form in all 4 positions of the problem. The top left numerator is a difference of squares and needs to be factored. the bottom right binomial can be factored. Let's factor the difference of squares. Two groups of parentheses, a plus x and a minus x. Underneath the bar is the a squared. Now times. There's an a up here, and underneath the fraction bar, we're going to factor the binomial. There's a GCF of 3. 3 times x creates the 3x. And 3 times minus a creates the minus 3a. Now we do the canceling. But something unique happens that's happened before. We have a difference, a minus x in the top and x minus a in the bottom. Those are almost common factors. They're just the reverse of each other. So what we do in this case is we factor out a negative to make them be common factors. I'm going to do that below. I'm going to take the x minus a and factor out a negative so that I can change it to a minus x. I'm replacing the 3 times x minus a with the negative 3 times a minus x. Now I'm ready for the canceling. A minus x in the top cancels away the a minus x in the bottom. The single letter a in the top cancels one of these away, leaving the new exponent of 1. Now the final answer. A plus x is in the numerator. Down in the bottom, there's an a, and there's a negative 3. It's customary to write the number in front of the letter, so we get negative 3a. So after doing a few of these, do you recognize the process? The first thing you do is you factor all polynomials that are in the multiplication problem. Then you can cancel. So let's find all of the polynomials. This polynomial can be factored. It's going to have a GCF. And this polynomial down here can be factored because it has a GCF. We can factor out the letter b. b times 4b makes the 4b squared, and b times negative 3 makes the negative 3b. Now there's a times dot and a fraction line, 5b squared in the top. Now let's make the factored form of the bottom right denominator. 10 divides into 40 and 30, and b squared divides into both terms as well. 10 times 4 is the 40, and b squared times b is the b to the third power. 10 times 3 gets you the 30b squared. Now that we have the factored form, we can do the canceling. 4b minus 3 cancels away 4b minus 3. There's a 5 in the top and a 10 in the bottom. Those are both divisible by 5. 5 divided by 5 makes a 1. 10 divided by 5 makes a 2. The b squared that's in the top cancels the b squared that's in the bottom. In the numerator, there's a letter b left. In the denominator, there's only a 2. Okay, number 41 is multiplying fractions, and in these fractions there are polynomials. This polynomial can be factored. It's going to have a GCF, and this trinomial can be factored. Let's rewrite 10x to the fourth power over, factor out a 6. 6 times x is the 6x. 6 times the minus 2 is the minus 12. Now the other fraction. The trinomial will factor with 2 sets of parentheses. X times x is the x squared. Negative 2 times positive 1 makes the negative 2 and adds together to make negative 1. and the bottom is 4x. Now the canceling. The x minus 2 cancels out the x minus 2. The 10 that's in the top and the 6 that's in the bottom are both divisible by 2. 10 divided by 2 makes 5, and 6 divided by 2 makes a 3. The single x that's in the bottom can be used to cancel one of these x's away, creating the new exponent of 3. The final answer is 5x to the third power, parenthesis, x plus 1, over, and in the bottom it looks like there's a 3 and then later a times 4. That makes 12. Okay, problem 43 is the same idea. It's about multiplying fractions, but the fractions are built from polynomials. Everything can be factored. The trinomial here, the trinomial here, the binomial here, and the binomial here. We have to rewrite this problem in factored form. Let's start with the trinomial. N times n is the n squared. Negative 2 times negative 1 is positive 2 and adds together to negative 3. Now the bottom left. Two sets of parentheses. N times n is n squared, and positive 2 times positive 1 makes positive 2 and adds together to make positive 3. In the top right, there's a GCF of 8. 8 times n is 8n, and 8 times 1 is 8. In the bottom right, the GCF is 4. 4 times n is 4n, and 4 times 2 makes 8. Now the factoring. There's an n plus 1 and an n plus 1. The 8 over the 4 reduces. 8 divided by 4 makes 2, and 4 divided by 4 makes 1. That's all of the reducing that can be done. So in the numerator, let's collect what we have. Remember, coefficient numbers first, and then things that involve variables. So there's the 2, and then in parentheses an n minus 2, and in parentheses an n minus 1. Down in the bottom, there is an n plus 2 and another n plus 2. So the fast way to write that is n plus 2 squared. Number 45. This trinomial will factor, this will factor, this will factor, and this will factor. We need to rewrite this problem in its factored form. Trinomials factor with two groups of parentheses. T times t is t squared. Negative 4 times positive 2 makes negative 8 and adds together to make negative 2. Down in the bottom, I notice it's a difference of squares, but I also notice that the 4 minus t squared is written backwards, right? Standard form would have the t squared minus 4. So remember that when that occurs, you can factor out a negative to create the correct subtraction. So in place of the 4 minus t squared, I want to write negative and then t squared minus 4. That's what I'm going to end up factoring. So I'll have negative and then two groups of parentheses when you factor a difference of squares, t plus 2 and t minus 2. Now the top right, trinomials factor with two groups of parentheses. T times t is t squared. Negative 3 times negative 2 makes positive 6 and adds together to negative 5. In the bottom, two groups of parentheses. T times t is t squared. 4 times positive 3 is negative 12 and adds together to make negative 1. Now the canceling. There's a t minus 4 in the top and a t minus 4 in the bottom. There's a t plus 2 in the bottom and in the top. There's a t minus 2 in the bottom and in the top. That's all of the canceling. Final answer has t minus 3 in the top, and in the bottom there's a negative sign, don't lose that, and then t plus 3. Number 47. This trinomial will factor, this will factor, this will factor, and this will factor. All four components are going to factor. Trinomials factor with the two groups of parentheses. 3x times x is the 3x squared. To get negative 5, you've got to use a 5 and a 1, and you have to position them in order to get the negative 14 that's in the middle. I'm going to use positive 1 and negative 5. Doing that, the outer product is negative 15x and the inner is positive 1x. Those add together to negative 14x. In the bottom, there's a GCF, 4x. 4x times 2x is the 8x squared. 4x times negative 3 is the negative 12x. Now the top right, there's a GCF. 8 and 18 both divide by 2. 2 times 4x squared makes the 8x squared, and 2 times a minus 9 makes the minus 18. But 4x squared minus 9 is a difference of squares. This factors farther. A difference of squares factors with two groups of parentheses. 2x times 2x and plus 3 and minus 3. So I'm going to cross this out and use the factored form written in red. Now in the bottom, two groups of parentheses. What times what makes this 3x squared? That would be 3x and x. Now what times what makes a 1? And notice the middle's positive, so I want positive numbers. It's positive 1 and positive 1. Now the canceling. There's a 3x plus 1 in the top and a 3x plus 1 in the bottom. There's a 2x minus 3 in the bottom and a 2x minus 3 in the top. There's a 2 in the top and a 4 in the bottom. Those both divide by 2. So I'm going to cross out the 2 and make it be a 1, and cross out the 4 and make it be a 2. That's all of the reducing that I notice. In the top, there is an x minus 5, and then later a 2x plus 3. In the bottom, there's a 2. And it's hard to see it, but there's an x. And then later on, in parentheses, there's an x plus 1. This concludes the video.